Welcome to my classroom. This is where the action takes place, at least for me. Behind me is my lab table. You can see it's a little bit messy. But what I want to point out to you is that right over here, as a reminder to both me and my students, I have a copy of the science practices. So as the next generation standards start to take hold and we make curricular changes, these practices form the basis of what I think students should be able to do in a science class. And so over the next couple months, we're going to take a look at some different ways that technology can help us and help our students meet those science practices. So now we've changed our view, and behind me, just waiting for those students to come in and start working, is my lab. And this is the place where the real action takes place, where students get to do science. And so the science practices set out those things that students should be able to do. And over the next couple of videos, what you'll see is how we can integrate technology. But in this month, what we're going to take a look at is how students can ask questions and define problems, how they can use models as a part of their work in order to be able to support arguments, and then finally, how can students plan and conduct their own investigations? And that can be a really tough task, but I think that there are some ways that we can break it down for students and technology tools that can really help them to learn how to do these authentic science tasks. Let's take a look.
You can find access to the science and engineering practices pretty easily, and it'll give you documents that look like this that you can share with your students. In this month's episode, we're going to take a look at asking questions and defining problems, developing and using models, and planning and carrying out investigations. So how can we get started creating a culture where our students start to ask questions? Well, one of the places that we can do this is on our websites. So this is my main website, and what I want you to see is that I have a place right on the front page that says Ask a Question. So students can ask a question about the current topic that we're studying, they hit submit, and then that question comes to me. It sends me an email so I know what kinds of questions the students are asking, and when we get good questions, we can award our students extra credit if we seem like that's a good idea. So I'm jumped over to the Google form where I put in my question, right? And I'll be able to see any responses I get, but I've asked my question. Was your question? And I wanted to show you that because we're a Google Apps for Education school, I can click on the little gear and I can collect their username. So I know who's sending me the question. I don't even need to ask for the student's name. I can also set it so that they can only ask one question if it becomes an issue for you. Right? So I'll hit save for that. And then I want to be able to embed my form. So one of the ways that I can do that, or at least get my information to students, is I could send it via an email, I could create a link, and I could even shorten the URL so that I could post this up on my board somewhere. So I could put that in large letters at the top of my classroom, but I also have a little embed link here, the little brackets that you see, and then this will give me the source code I need if you have a website or some type of learning management tool. You can usually embed things right in there, and so that might be a little bit more of an advanced skill, but it allows you to put it right where the students might be looking for when they need to ask a question of you. Well, as we think about students asking questions, in an earlier episode we had talked about how they could add search operators to their Google searches. And if you think about a Google search, you're really just having students ask a question. So you can start to limit these questions, or at least the responses that you're going to get, by using search operators. So by searching a particular site would allow you. So you can see in their example there, they want to look up Olympics, but they're going to look it up at either a government site or at NBC. So these types of search operators will allow you to be able to sort of refine your questions. And when we think about students doing research, that's an important task for them. If you're a school that allows BYOD, you can take advantage of Siri or Cortana or whatever other type of voice-activated search. So get your students out, have them get their phone out and say, "Hey Siri," and what's the best question, science question that they can ask, and then Siri or Cortana or whoever it is will be trying to give them those answers. Now, when we talk about shortening the URL, I use Google, but there are others like TinyURL or MooURL. You saw that in the form, so you can put that information in so that students can start to ask those questions. And asking questions is really about creating a culture where students are encouraged to do it. In the article, we talk about using like a TV show and asking what questions might come up. I love using clips of the Big Bang Theory where they talk about science and then asking students, well, what questions do you have based off of what they just said? So we want to encourage our students to be good questioners, to ask those questions, and then to try and find that information. If you have a student for a year-long class, you might consider having them keep a blog or a class blog where students can pose questions and try and put those answers down as they go. Now, the second piece of the science practices is to develop and use models. Now, there are lots of sites that you can go to do this. The Concord Consortium, if you look up under the STEM resources, you'll find a whole bunch of different models. And we start thinking about, like, here's a model that students can use, and it says, try to get results similar to Rutherford by adjusting how the central positive charge is spread out. Well, you don't have to give students like a document that has questions. You can actually give them the simulation or the model and ask them to play around with it and then see what types of things they can do with it. Another site that we like to use is the Go Labs site. They have a whole bunch of labs that will fit into a sort of a certain type of pattern for you. And you can see it says create an inquiry space. Well, when you create that inquiry space, what's interesting about this is that it breaks it down into different sections for you. So you can talk about like the orientation, the conceptualization, and the investigation. And when you go to the investigation, this is where you're able to actually do some things in the lab. So you can adjust the mass or the volume. You can, so if we have like mass and volume, we adjust that, and you can sort of see that first object is changing, and then we can go down and we can say, okay, run, and it will give us results as to whether it sinks or it floats. And so we can ask all kinds of questions like what happens if I raise the mass or the volume, okay? And then maybe why are they tied together, as we work through that. So another great site to get simulations like this is the PhET site. Of course, if you're going to use that site, you may want to consider donating to the program. And one of the things I wanted to point out is that you'll notice that they have little icons on here. And we've had trouble running JavaScript because we have to actually use an old version of Java. And so they are currently moving theirs over to HTML5, so you can tell the difference between the simulations here. HTML5 will run in any modern browser. And so if you choose something like this, like the John Travoltage one, we click under for teachers, you'll see there's a whole bunch of resources that have been uploaded by users, and that's great for getting you started. But I like to think about some of the simple simulations like this. Like I have a simulation, and I can just say, okay, well, what happens when you rub the foot, okay, or what happens when you bring, the finger near it. And what happens if you rub the foot for a longer time? Or what questions might you be able to come up with, like based off of the simulation? Why are they using John Travolta? Things like that come up. So using these models can be a great way to get students to go back towards asking questions, but also provide you with a glimpse of how things work in the world for things they might not be able to see. The last area that we talked about this month was planning and carrying out investigations. And what I'll tell you is that we have a template that we use for our students that identifies the scientific method. So you can see like we've identified the 7 steps that we use, and then we've defined them up here. And the idea is that students would use this to fill in the different pieces as they go about planning and conducting an experiment. And this can be really difficult for students. So one way that you can get started with it is just to have, perhaps you fill in many of these bubbles, but you leave one bubble blank for students. And when students actually do this, they can use this as a write-up. So you can start to see, like, I have my same 7 steps, but what students did in this case is they have attached things, like where it says analyzing data, and they point to it, and they write their analysis and conclusion, and they link out their data. And so this is a non-traditional way of reporting on a lab. Now that's the end piece. Of course, the planning piece can be done with tools like concept maps. So we use Lucidchart for a lot of our concept mapping. And the idea here is that students can bring arrows out, and they can start to step over here, and they can bring out text blocks and little notes and things like that. And so they can bring them out as they describe the lab. So if you are going over a lab, you may want to have students sketching this out. They can work on this collaboratively. Okay, you can see where the share button is. They can share it with the person. They can work at the same time, and so students can build a plan for carrying out their investigation live as you discuss it in class. Sometimes I give my students the problem, and I might have them design like a short little experiment or a presentation. Like in this case, it's steeper versus shallower on a ramp, and I ask my students, what's the problem, or what's the question they're going to investigate? How will they be measuring things? What will they be measuring? And then how will they conduct their analysis? By having them do this ahead of time, it really helps them to be able to plan and really carry out the investigation, because they can go back and they can set those notes up for themselves. So there are all kinds of tools that you can use in the same way in order to be able to help them sort of build out their inquiry-based learning. So hopefully you've seen how we can use technology to get started in using and making the science practices come alive in our classroom. Next month, we're going to take a look at, now that you have planned and you've conducted your investigation, you have this data, how can you analyze and interpret the data and use computational thinking as a part of your problem-solving process?